Hello everyone. Before anything, I wanted to thank each and everyone in the organizing committee for allowing us to attend and for giving us this opportunity to present our own work. My name is Rajae Sammani. I'm currently a PhD student at the Laboratory of High Energy Physics, Modeling and Simulation here at Rabat Science Faculty. I'm working on investigating holography using swampland program principles. Particularly, I'm working on several ADS3 models, including higher spin gravity, massive ADS3 gravity, and massive higher spin gravity. And today I will share with you how we were able to show and demonstrate the finiteness of the higher spin ADS3 gravity landscape using swampland principle in accordance with the finiteness conjecture. For this purpose, we had to construct the higher spin ADS3 gravity landscape. And in order to do this, we principally embed the core SL2R symmetry in multiple real forms of higher spin symmetries. The realization of this principal embedding was possible by cutting one of the extremal nodes in the corresponding Titsatake diagrams. And the results included two possible higher spin spectrums. We denoted the first one as vectorial and the second one as spin. These both higher spin possible decompositions happen to be identical for the SLNR algebra. We also constructed a parallel landscape for the associated BTZ black hole solutions of these higher spin gravity models. And one very interesting feature was how, unless one is considering trivial holonomies, there are actually no continuous path joining the core BTZ black hole to higher spin BTZ black hole. The second step is the choice of boundary conditions. One of the most general boundary conditions were proposed by Grumeler and Rickler, and they gave two copies of the asymptotic symmetries given by the affine algebra of the associated symmetry one is considering at the bulk. However, in order to do this, they only considered the variation of the charges without the chemical potential, which is understandable because this helps to cancel the gauge anomalies at the boundary of the theory. So if we wanted to extend those boundary conditions, we had to consider the variation of both charges and chemical potential. And this resulted in 4 copies of the asymptotic symmetries given by 4 copies of the affine algebra, 2 for each sector. But this left us with a gauge anomaly at the boundary that we had to find another way to cancel without imposing the non-variation of the chemical potential. We had to formulate an anomaly in flow mechanism by introducing strings at the boundary. And we did this by exploiting the Chern-Simon-Wieso-Minuiten duality. The fourth step is to check for the validity of the finiteness conjecture, and we did this using the CFT central charges. We were able to compute an upper bound on the rank of the higher spin symmetries, which allowed us to prove the finiteness of the landscape. Furthermore, by imposing suitable constraints on the Chern-Simon level, the finiteness constraint can actually lead to the gravitational exclusion principle, which was previously computed using consideration from the statistical thermodynamics of the BTZ black hole. That will be all for today. Thank you so much for your attention.